go ahead.
Thank you. And as said before, I'm not a scientist, unlike most of the speakers in this marathon. I'm a journalist and I'm an amateur astronomer. So I invite you to follow me on a moon trip just for fun. And I hope I will make you eager to have a telescope and to observe through or to go in the street to observe through some many telescopes for the moon again on the moon again day. So there are a lot of things to see on the moon, big craters like Copernic, Tycho, etc. But when I was young, I was born during the Apollo era. I began to explore the near side of the moon with a small refractor. It was in the 80s. You see on the screen the 6 Apollo lunar landing sites. So I have today, right now, I have 2 telescopes. The left one is a 8-inch Newtonian telescope, and the right one is a Maksutov 7-inch telescope in diameter. So as you can see on the pictures, I am in town, so there is no problem to observe the moon from a town or a city. And well, for many years, I never stopped being fond of the Apollo exploration. I look at the moon every time, and I discover it was interesting to look for some details around the Apollo landing site. By the way, I wrote a book recently to make you be sure how much I'm fond of the Apollo era. It's a 520-page book telling in depth the exploration driven on the moon by the 12 men who were there. Unfortunately for you guys, it's in French, as you can see, so you can improve your French speaking, or at best, you can help me to find a publisher to print it for the United States and the rest of the world. Well, get back to our topic. Here is again the map where you see the 6 Apollo landing sites. All of them, of course, on the near side of the moon. And so the question is, what can we see? Here is a picture taken by the Lunar Reconnaissance Orbiter, LRO. And you can see the scale at the bottom left, 50 meters. And of course, this picture is a very high resolution picture of the surface of the moon. You can see the LM it's the lunar module, the descent stage of the Apollo 11 lunar module. And you can see also the tracks left on the moon by the footstep of the 2 astronauts, Armstrong and Aldrin. First, of course, there is no way to see something like this, like the descent stage with a telescope. Just for your information, this part of the spacecraft you can see on the picture is only 7 meters wide, and even with 8 meters aperture telescope and adaptive optics, there is no chance to see it. The angular resolution of such an instrument is 0.05 arcsecond, which means about 30 meters on the lunar surface. So roughly, it's the scale you can see on the bottom of the picture. With an 8-inch telescope, which is a standard, which is not a big telescope today for an amateur, the resolution is roughly 0.7 arcsecond. The tiniest feature that you can glimpse is no less than 1.3 kilometers wide. So what the hell can we see? Well, firstly, you can pinpoint the exact landing site of Apollo. I will show you in the next slides. Secondly, you can identify some of the lunar features the astronaut saw just before they landed, and in some cases, once they had landed. Thirdly, for the three last missions, the crews had a fantastic thing with them, the Lunar Rover vehicle, the LRV. Thanks to this smart all-terrain vehicle, they pushed their explorations up to 7 kilometers away from their lunar module. That give us a chance to see something. Fourthly, all that you want to see, keep in mind that it's on the moon, the brightest celestial object after the sun. This light point takes all significance when you know that due to the very dark shadows of some craters or mountains or ridge or lava flows, you can have a huge contrast in your picture and you can glimpse details smaller than the resolution of the telescope. So there are many observations to do on the Apollo landing sites with an amateur telescope, at least as interesting as on any other part of the moon. Let's see some example. If someone asks you, for example, tonight, to show him or her where exactly Neil Armstrong set foot on the moon, as he was the first human being to walk on the moon, no worry, it's easy. On the southern limit of the Sea of Tranquility, where the arrow is pointing, there is a good landmark as a small crater named Mocktail. It's a 6.5 kilometer in diameter, but surrounded by a bright corona ejecta. It's easy to see this crater through a telescope. Here is the phase of the moon 3 days ago, exactly. And if we zoom a little bit, you can see Apollo 11 in the middle, and just under the Apollo 11 mark, you can see the small Mocktail Crater. Here is a photograph picture taken by a fellow amateur. Of course, if you observe by eye through a telescope, it will be a little bit smaller, but you can see all these details. So the Mocktail Crater is right in the bottom middle, and just under the crater, you can see a line, a small trench. In fact, it's many kilometers long and more than 1.5 kilometers wide, which name is Rima Hypatia, or Highway 1. The name Highway 1 is because when the astronaut of Apollo 8 missions flew over the moon, they looked for a site for the first lunar landing, and they noticed some landmarks like that, and they named it because Highway 1 was right in the direction they had to follow in order to land. So they dubbed some feature like that. Another feature you can see easily through a telescope with a moderate magnification is Mount Marilyn here. Mount Marilyn, nothing to do with Marilyn Monroe. Marilyn was the wife of one of the astronauts of Apollo 8 mission. And Rima Hypatia 1 and Mount Marilyn are very easy to see through a telescope under good light conditions. If you have a low sun angle, that's better. If you are near to the full moon, you will see nothing, of course. And the first explorer of the moon gave their names, not them, but the International Astronomical Union gave their names to 3 small craters just in the vicinity of their landing point. So Armstrong, Collins, and Aldrin. And there's 3 craters Armstrong is a little bit bigger, but Collins and Aldrin are about 2.5 kilometers. That's that's okay for the resolution of an amateur telescope. So if you see Collins, you are not far from the landing site. It's about 17 kilometers south to Collins. Here is a high resolution photograph, and I experienced the stuff. Yes, we can see this small cluster of craters, which is 3.6 kilometer wide, which name is cat's paw. It's obvious because of its shape. It's like if a cat step a foot on the moon, and it's not very deep, so it's difficult to see because you have no contrast. You can understand that 3.6 kilometer. Okay, it's easy for a telescope because it's okay for the resolution, but it's not very contrasted. So you need a very low sun angle to see it in order to have a shadow inside the crater. And this cat's paw crater is 5.5 kilometers to the actual landing site. So you can pinpoint the Apollo 11 landing site much more, with much more accuracy than the flight controller at the time, because they didn't know where Armstrong landed, because there was a shift in the trajectory. So they knew that only weeks after the crew returned safely on Earth. So that, I think, it's the best thing you can see for Apollo 11 landing site. That's exciting when you are trying to see this feature, and when you see cat's paw, you are thinking, okay, I'm very close to the landing site. Here is a picture taken from the JAXA Selene probe, or Kaguya. You can see the cat's paw, of course. It's a very high resolution picture. And the area brightness by engine exhaust, that's right. That's the point where the lunar module landed. And I show you that just for fun, because when Armstrong was on the moon like this, of course, he took some picture of the landing site. And in this one, you can see the horizon line. It's not straight. You can see a small hill on the horizon. And if you study this in details, you can see it's actually the cat's paw crater. You can interpret that like that, and it's pretty sure they saw cat's paw crater from the lunar module and from the soil, from the ground when they walked on the moon. Here is another picture. You can see the lunar module, and in the horizon, the 2 hills marking the limits, the rim of the cat's paw crater. So come back tonight, or in a few hours, you will see the moon like that. And I will not, of course, explore all the Apollo landing site, but I will talk about the Apollo 15 landing site, which is in a very, very spectacular area on the moon. you can't miss it when you observe even with binoculars. That's the Apennine range, huge mountains, about 3,000 meters high, and the Apollo landing site was right where you can see the blue cross, near mountains, high mountains, and a specific feature, which is this kind of valley. One of the previous speakers told you about that, the Adler Hill. And for this mission, the astronaut had this stuff, this fantastic rover, and thanks to that, they could conduct free EVA, extravehicular activities, free exploration, kilometers away from their lunar module. And on the first EVA, they were near this crater. It's rather easy to see it through a telescope, and which name is Saint George. It's named after the French wine Nuit Saint George. I don't tell you why, because we have no time, but it was a joke and a bet between astronauts at the time, and they forget the S at the end of George. Okay. And you can see they were very, very close on the rim of Adler Hill. This is an orbital view, and actually they reach the Elbow Crater, which is 340 meters wide. So is it impossible to see through a telescope? Yes, if we stay stuck by the resolution of a telescope, but thanks to the shadow, I think we can see it. I never saw it, but perhaps with a 10-inch or 12-inch telescope, you have better contrast and you can have a glimpse of this crater. And from Elbow Crater, the astronaut can observe the bottom of the Adler Hill here in this photograph. They conducted many others, two others EVAs. This one was the second on the foot of one of the mountains, and they took this kind of photo with 500 millimeter lens. The lunar module is 5 kilometers away. That's impressive. And the only feature you can recognize for this second EVA is a cluster of craters named South Cluster. It's not very contrasted, but you can glimpse a subtle change of the color. So that's the best way. And finally, they went to the rim of the Adler Hill, and it's during their EVA3, and you can see where it is, because the Adler Hill makes a little promontory at this point, so you can see through a telescope some of the place the astronauts were. And finally, at the top of this picture, you can see a North Complex. They plan to be there. It's a hill with a crater, pretty visible in an amateur telescope, but they didn't have time to go there. Okay, I'm quickly give you a shot on Apollo 16, which is not easy to identify because it's in the middle of highland terrain in the moon, in a plateau. Just for information, the astronaut climbed a hill many kilometers to their lunar module, and this hill was Stone Mountain in the bottom right of the picture, and they were close to South Ray, 300 meters in diameter crater, of course, smaller than the resolution of your telescope, but you can see, because as you can see on this picture, it's very bright around the crater. It's a very young crater. I think it's 25 million years only, which is young on the moon. And they went to the north, on the rim of North Ray, another crater 1 kilometer wide on the footstep of Smoky Mountain. There are bright material around this crater also, and you can see the two craters surrounding the landing point, the blue cross in the middle of the picture. Here is a picture of North Ray taken by the astronauts, and here an astronaut on this rim. In the background, you can see a big boulder, house rock. They went to this rock and picked up some samples. They returned to Earth. Well, let's go to the last destination of my presentation. I will be brief. The Apollo 17 landing site, very impressive, like Apollo 15. It's a valley, very dark material on the ground and surrounded by a lot of big mountains like this. And the fact on this landing site is that the astronaut went to the west 7.5 kilometers to their lunar module, and on the other side to the east it was about 4 kilometers. So between their farthest points there was 12 kilometers, very easy to see through a telescope. So here is a map of their trip on the moon. You have only to keep in mind that the best thing to see is Tortilla Flat. Do you know what it is? It's the result of a landslide from South Massif. Scientists think that this landslide was provoked by an impact, a crater, and all the material was going down the slope, and that was a landslide, a huge landslide, an avalanche, and the astronauts were there. Can we see? Okay, here you have the Gene Cernan at the footstep of South Massif. Here is another thing they saw. It's a scarp. It's a little fault going through the valley, and it's like you know, it's on this slide. It's named scarp at the bottom, at the left of the picture, and they climbed this, and I think we can see that like a bright white line across the valley. Here is a amateur photograph. I think it was by the American amateur Wes Higgins, and you can see in the middle, you can glimpse the scarp here. And that's all what you can see from the lunar, the Apollo 17 landing site. But all the mountains all around are very impressive. That's a very, very good spot to observe. The last thing, as you can see on this picture, the lunar module was just right to a rather big crater, which name is Camelo. The astronaut take this panorama on Camelo crater. They picked some samples, and this is a 600 meters crater in diameter. So if you have a good telescope with a very low sun angle, you can hope to see it. Of course, you will not see, and that's the last picture, you will not see these boulders on the slope of North Massif, but you can imagine you were part of the trip, And that's why I invite you to try to find that through your telescope or to a telescope by a club or in the street right now during this On the Moon Again event. Thank you. You have here a map showing all the Apollo landing site in green, but also you can play to find some probe landing site, Lunar for the Soviets one, and the Surveyor. And this map does not mention the Chang'e landing site, Chang'e 3 and 5 near the Marienbrüum or Rumker hills to the north of the moon. I thank you. I think I'm behind the schedule now.
Hi. Thank you very much. Could you please stop the
Yes.
presentation mode, please? And then we can move to the Q&A session. Thank you. Thank you very much for this very interesting presentation, very nice resolution images, and for all these tips that you gave, which were quite useful. And who don't have a telescope, then they simply can join different people who are observing in their cities, and this is always a nice opportunity to share the observations with other people and explain to them what is in the camera. So thank you very much. We have plenty of questions.
Wow.
Yeah, well, the presentation was absolutely brilliant, and it's always a pleasure to see Apollo pictures. And again, it's always really, really fascinating. I wanted to come back. So in the chat, if you have any questions, you're always welcome to ask them. And well, meanwhile, I've got some. We've got all together some questions. I remember you started the presentation saying that you were not a scientist, but an astronomer and journalist. I was wondering, in your point of view, what's in an event like On the Moon Again, in the streets with telescopes, talking with people, what can an astronomer and a journalist bring to the people around them? How can they enlighten people? But have you experienced it yourself? Do you share it?
Yeah, it's the second time On the Moon Again is an event, and the first time I played like an astronomer amateur. I was in my little village. I was in holidays, and I have my Newtonian telescope, and I put it on the street, and half of the population of the small village came, and they never had a chance to see a telescope and to see the moon. And there was, I remember, there was Jupiter and Saturn also, and they were struck by the picture. And I think, to answer your question, our role is to show how fantastic it's only to have a look into a telescope, because when it's the first time you see the moon, even if the atmosphere is not steady, even if the pictures are not good, you're very impressed by what you see for the first time. And it's a way to invite people to be interested in science. Because that's not hard, that's fun, and that's the message we have to tell them. And that the best way is to show them the Saturn rings. You know, when you look Saturn rings through a telescope, you are very impressed by the relief. That's incredible. When you see the mountain and the crater on the moon with the shadows, it's like you were in a spacecraft around the moon. So
yeah, first time you see it,
it might be inspiring. Yes.
And actually, I think that's also a way to put first step in science and learn things when you buy a telescope and watch and watch and watch again.
And you know, as a journalist, I don't do science, of course, but I'm telling stories, and all the stories of the Apollo exploration, they are human stories, and that's fascinating. Some humans were around the moon, and they were not very able to tell us what they saw, but it's our work to to dig in what they saw and to tell the others, because this is an extraordinary adventure. So we have to share that, to understand what they do, what they did, what they were looking for. Geology, it's not very fun at the first sight, but if you tell story of the astronaut looking for a crater, be lost on the moon with a lot of uncertainty, with technical issues, all that, you are telling a story, and that's fascinating.
Yeah, that brings the sparks into joint. The astronaut did their part, and they did their job, and yours is to tell theirs.
Exactly.
Really fascinating.
This is what's really exciting about the observations is always the first wow effect. I don't know if the people who joined us recently were watching the videos yesterday, but many people were noticing, like, we can see our moon almost every day, but it's another way to rediscover and see all those details that mostly we don't pay attention to. And then after the wow effect comes the curiosity and the will to know more about the moon and the planetary science in general.
Yeah, sure. And you know, I focused my presentation on the observation of the Apollo landing site. That was a kind of play at the beginning, but you can see when you begin this play, you want to see more, and you have a purpose when you are observing the moon. I could have tell you the story of the Lunar 2, the Soviet probe. He traveled about 40 kilometers through Le Mocktail Crater on the moon, and you can see the feature he visited. So it's a way it's a door to observing the moon. Of course, it could be difficult because you are looking for very tiny details, but you have to begin. You begin by the Apollo 15 landing site with the huge mountains, with very impressive mountains with relief, and you want to be there. So you want to go further.
And going from that, do you remember the first time you looked through a telescope? What did you look at and what did you feel?
Yeah, I was 12 years old. I had a very small refractor. It was a Christmas gift. And I tried, of course, to see the moon through. And I was not a good astronomer at that time. And I didn't manage to make the focus. So it was blurred. It was out of focus, and it was very deceptive because I was alone with my instrument. So I invite the people to go to see other amateurs in clubs, in institution or near their home. These people really share what they know, and that make you big. You make big improvement really fast. on my side, my first look in the telescope was very deceptive. But I tried again, and finally it was fantastic.
Yeah, and doing that journey alone is, well, fantastic, but doing it as a group is,
Yeah,
as you mentioned,
it's better because during, for example, I made a mistake during 2 or 3 years. I used my telescope with a Barlow lens, which makes your magnification twice the and it's too huge, so I didn't see, for example, all the light from the Orion Nebula, I didn't understand why can I not see what they say in books, and it was a mistake of mine. So I learned by these mistakes, but it takes time. So go to see who knows, and you will make improvement very, very quick, very fast, and it's a great adventure.
Yeah, making mistakes is normal, but in a group it can be corrected.
Yeah, when you are alone, it takes time to understand all that stuff. But with others, it's like that.
Yeah, it was easier. I think we've almost reached the end of our time. I think we might have time for one last question. That might not be an easy one, but I think it's interesting. I know that at Ciel Espace you recently published a special magazine about fake news. I haven't had the chance to read it yet, but I've heard great things about it, so it's only a matter of time. And I was wondering, since you said you took part in that kind of events, sharing your passion to other people, how do you manage to deal with people that come with doubts, and what's in your way the best approach to have to talk and have a discussion with people spreading fake news?
Well, I did a lot of lecture, especially on the moon, and it's a topic where people who don't believe men were not on the moon are numerous. So I had a lot of question about that, and the best thing is to talk. And I I have to confess that when I was young, I was part of them because I ignored all the scientific method, and you can be of good faith and believe wrong things. So we have to talk with the people, the one who don't want to know or to understand. There is no way with him, but the others, the good faith ones, you have to show them that it's a long way to understand what happened, why it's true, why it can be, and I have no I have no magic solution, but I think to talk, to listen what the people believe, what they say, and to try to give them some arguments. So no, that's not a good word in English. Sorry, but some reason to believe what the story says. So the best way is to, and that's the way we try to do by this issue you mentioned just before. We try to talk people, to show them that there is no fake story about the moon, for example, and other stuff. So talk. That's the only way, I think.
Well,
thank you very much.
Thank you.
It's all about learning how to use your instrument and scientific methods. And thank you very much for this interesting talk and the invitation and the way you encourage our audience to go and observe in different.
Yeah. Go out and observe. Yeah. Thank you, and
Thank you.
good luck for the end of this huge journey.
Thank you very much.
Bye-bye.
Bye.
Bye-bye.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps. descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.